This is our planet, the Earth. It's an amazing, ever-changing world full of natural wonders. But there's more to Earth than this, much more. Because our planet is unique in the solar system, perhaps even in the universe. 4.5 billion years have made it a world of extraordinary landscapes and a home to life. My name's Ian Stewart, and I want to show you how our remarkable planet works. In this series, I'm going to explore the 4 powerful forces that have come together to create our world. The oceans, that have the power of life and death over all living things. The atmosphere, the most fickle of forces. It drives our climate and protects and nourishes us. Ice. It has carved the world we know and changed the course of human evolution. But I'm going to start with volcanoes. They're terrifyingly destructive, but they're also the most fundamental force on the planet. Volcanoes are part of a global system that continually reshapes our world. They hold the key to the origins of life on Earth. They saved the planet from the biggest crisis it's ever faced. And they've even formed a partnership with life that keeps our planet habitable. Ethiopia, Eastern Africa. This is the Afar region, bandit country, so I've hitched a lift with the Ethiopian military.
I'm off to one of the hottest and remotest places on the surface of our planet to see the most powerful force on Earth in action.
We've got plenty of equipment because ahead of us there's some serious climbing. We've touched down on a dry, brittle surface of recently cooled lava. Once the helicopter leaves, we're on our own for a couple of days. This place has no water, no shelter, no life. Except, I'm told, for a few snakes. But I think it's really going to be worth it. I've come all this way to see one of the most remarkable volcanoes anywhere on the planet. Terra. The name means the smoking mountain to the local Afar people. It's reckoned this volcano has been continuously erupting lava for longer than any other on Earth, though no one's quite sure because it's only been properly studied for the last 40 years. I've been lucky to see a lot of volcanoes in my time, but I've never seen one that has a permanent lake of molten lava in its crater. But there's another reason why this volcano is very special. And to see that, I need to get down into the crater and see the lava up close.
How's that feel?
That's fine.
But the rocks here are very sharp and very brittle, so it's actually good that we're on an overhang and that we're not going to actually crash into them.
Okay.
Nervous?
Yeah, a little bit nervous, apprehensive really. You know, it's, you know, first time you're ever going to abseil. You kind of didn't want it to be down into an active volcano, but hey. And then the ledges. So this is my one now.
Sit back, sit back.
After.
Ready, sir? Okay. That's it, that's good.
It's a 30-metre vertical drop to reach a wide terrace below. And the lava lake itself is a little further down. I've waited until sunset to take a closer look because the lava is at its most spectacular at night. This is as close as I can safely get.
Oh wow, look at that. That is magnificent. I mean it's taken us a hell of a journey to get here, but that makes it all worth it. I'm standing on the edge of an active volcano, right next to a big pool of molten lava.
What makes this lava lake more than just pure spectacle is that it's a window that allows us to look deep into the Earth. And it helps us understand the forces that shape our planet. Just take a look at the motion of the lava lake speeded up. Something intriguing is happening. The movement of the lava follows a very distinctive pattern. It wells up on one side of the crater and forms a dark crust as it cools. Then this crust moves across the surface of the lake, driven by the churning action of the lava below. Finally, the crust sinks back down. As we'll discover, this process of molten rock churning away below the surface affects our entire planet. That's because this lava lake is connected to a gigantic source of heat that lies deep inside the Earth.
I think it's fair to say that most of us go about our daily lives completely unaware that underneath our feet, our planet is incredibly hot. I mean, we live on a thin skin of cool rock, precariously located between the cold freezer of space up there and a red-hot furnace down there.
And what a source of power this furnace is. The Earth's heat does far more than just fuel volcanoes. It created the first atmosphere in the oceans. It continually reshapes the planet's surface, builds great mountain ranges, and moves entire continents. And it created the conditions for life on Earth to begin. In fact, you could say that the whole history of the planet has been driven by the massive heat trapped inside it.
To understand where our planet's inner heat comes from, we have to go back 4.5 billion years to the time of Earth's own birth. It was a period called the Hadean, after Hades, the kingdom of hell, which is a good name because this was a hot, hostile and violent world.
You may not recognize it, but this is our planet in its very earliest days. Little more than a few pieces of rock colliding as they circle the sun. These impacts were so violent they generated immense amounts of heat. And they also delivered vast quantities of radioactive material to the Earth. Eventually, when the outer layers of the planet cooled, these two powerful sources of heat were trapped in a huge hot core. The center of our planet is as hot as the surface of the sun. This is the source of Earth's vast heat energy. And it's what fuels volcanoes to this day. Trapped within our planet, Earth's hot core has been continuously releasing unimaginable amounts of heat. It gives you some idea how much when you realise that even after 4.5 billion years, there's still plenty left. Earth's inner heat makes the planet's surface incredibly dynamic. It has created a restless, continually changing landscape unlike any other in the solar system. It's a world of destruction and renewal.